Good morning. This is Mr. Reynolds, and like I promised you yesterday, you're gonna have a little bit of math stuff. So if you stop this right now and get a periodic table, that would be the best thing to do. Okay, this is a continuation of one thing that you were learning last week. If you remember doing the mass, where we converted mass into moles, and then we converted it into number of particles. Okay. And the particles, well, that's a weird word. Well, it could be individual atoms. It could be nonmetals bonded to nonmetals, which we can call molecules. Or in ionic compounds, we're supposed to call them formula units. Okay, so right now we're just calling it all different particles, whichever. This is a play on terms here. Like I said, you work it out the same way. Okay, and things that we reviewed before. We said going to the moles box, going to the moles box, you divide. Going to the moles box, you divide. Going away from the moles box, you multiply. Okay, and basically we're going to start out with the mass of the substance. All right, we're going to start out with its mass. You can put it on a triple beam balance and you get the mass of it. If you can do that, you can figure out any of these other ones. Okay, if you know how many particles there are, well, you know, you can backtrack. You can go to moles, you can go to mass. You can find any of these out once you know one of these. But we're pretty much always going to start with the mass. So let's do that. You're going to have 5 grams of sodium chloride. Let's say we weighed out in table salt, we weighed out 5 grams of sodium chloride. Okay, I think there's 4 steps to this. I'm going to try to get it all on this page so you can do it. Other things, clean this up. You need to find the molar mass of whatever the substance is, and this first one's going to be sodium chloride. That's the conversion factor that we need. Over here on this other one, this is one math thing I need to teach you, where how we multiply in scientific notation. Okay, when we get over here to the moles box, when we convert 5 grams into so many moles, we're going to have to change that into scientific notation form. You did that a little bit yesterday. Okay, so this next step of multiplying by this, I'll teach you that. That's not too bad. Remember, in scientific notation form, it's supposed to be easier when you're dealing with big numbers or super small number, many small things. Okay, all right, step 1. Once you're given the substance, once you're given it and the amount, go ahead and find the molar mass. Find the molar mass of the substance. Find molar mass. And you've done this before. I'll review it again with you. And the substance is sodium chloride. And you were nice and neat with it before. Oh, we have a sodium, we have a chlorine. We've got 1 sodium, 1 chlorine. Each sodium has a mass of 23. Each chlorine has a mass of 35. So we can add those together and we get 58. So the overall molar mass is 58. Okay. Second step is going to go from mass. Now that we have the molar mass, and going from mass to moles is second step. So let's write that down. We're going from mass to moles. And you've got the chart in front of you to help you some. So to go from mass to moles, we have to take the 5 grams divided by the molar mass, which is 58, right? For sodium chloride, we're going to have to divide it by the molar mass. That's going to give that to us. So the mass, it's 5 grams divided by 58. Okay? Okay, when I take 5 grams divided by 58, I get 0.0862. All right, and this is going to be moles. Okay, if I take 5 grams divided by 58, I've got this. And to get this, we need to get this moles. So step 3, let's get this in scientific notation. We'll just work this out here so you can see it. That is going to be, I need one number in front, 8.62 times 10 to the, I had to move the decimal 1, 2 places to the right, so that's to the negative second. Okay, 8.62 times 10 to the negative second. All right, so this is number of moles. This is number of moles here. All right, we'll put the 8.62 times 10 to the negative second up here. This is where we are. We got one more step to go. And we're going to multiply moles times Avogadro's number, okay, which is the 6.022. So we had, for the moles, we had 8.62 times 10 to the negative second. We'll put parentheses around it since we have these x's in here all over the place. I don't need another x times sign here. So, and we're going to multiply it by 6.022 times 10 to the 23rd. Sorry, there's a lot of math in here, but it's kind of cool that whatever you start with, whatever, if you know the mass and the substance, you can find out how many particles are making that up. How many in a teaspoon of salt, if you know its mass, you can figure out exactly how many particles it has. You know the mass of ozone, O3, that was a molecule you worked with yesterday, I think. You had to look that up some. If you know its mass, you know how many O3 molecules are present. All right. So down here in step 4, last step, I'm taking the number of moles multiplied by 6.022 times 10 to the 23rd. So then here we are, number of moles multiplied by 6.02 times 10 to the 23rd, just like the chart tells us to do. And this is what we get. When I multiply this out, and all you have to do is punch in your calculator 8.62 multiplied by 6.022, and it gives you, mine gave me 51.90, okay, and then I just carry the times 10 stuff over. That's what makes it easier, except when I'm multiplying, I look at my exponents here. If I'm multiplying, I find the difference between those. That should be to the 21st. So 51, oops, sorry, I didn't clean it up yet. I need only one number in front of the decimal. So let's do that. Let's clean that up. So it should end being 5.190 times 10 to the, if I move it 1 to the left, that's a bigger number, to the 22nd. Okay, you did some of that yesterday, all right? Okay, this is the final answer for this one. So in 5 grams of sodium chloride, you're going to have this many. Wow, this is 1, 2, 3, and then 19 zeros after it. That many formula units of sodium chloride. Wow. We're going to go on to the next slide. Okay, let's do let's do another one quickly, and then this will be the last one. So again, you need the chart. You need to have the chart in front of you. Okay, so we're doing mass to moles to number of particles. The conversion factors, 6.022 times 10 to the 23rd. Up here we need the molar mass as conversion factor. Molar mass of that substance. Division signs going to the moles. Multiplication signs going away from the moles. I like boxes around these. It makes it look a little nicer. Okay, and remember, if we have the mass or the moles or the number of particles, you can find out all the other ones. We're always starting with mass here. So let's start with let's do some dry ice, which is carbon dioxide, and let's have 5 grams of that, just so you can see a difference in the last one. You know, we started with 5 grams, totally different substance. Okay, so number 1, find the molar mass. Okay, so nice and neat, or not so nice and neat. It will be nice and neat here. We got one carbon, we got two oxygens. Each oxygen has a mass of 16. Each carbon has a mass of 12. Add them up, and my molar mass for carbon dioxide is the 44. Okay. Step 2, I'm going to change from mass to moles, looking at the chart, okay, where I'm starting here, and I'm going over to the moles box, and it says I divide 5 grams. I'm going to take my 5 grams divided by the molar mass, which is 44. So 5 grams divided by 44 equals 5 grams divided by 44 equals 0.1136, etc., etc., etc. Okay, change it to when we want it to be in, that's moles. Okay, I said we want this, the third step, we want to change this into scientific notation. So 0.1136, change it into scientific notation form. I need one number in front of the decimal, 1.136 times 10 to the 1 to the right. I had to move it 1 to the right, -1. Okay? And then step 4, let's look at the chart and see where we are. We're right here at the moles box. We now have 1.136 times 10 to the -1st moles of carbon dioxide. And I want to see how many particles that means. So 1.136 times 10 to the -1st multiplied by 6.022 times 10 to the 23rd. All right, so that is step 4. 1.136 times 10 to the -1st in parentheses multiplied by Avogadro's number, 6.022 times 10 to the 23rd. And that's going to give me 6. Come on. This is going to give me 6.84, and that's the number. I already had one number in front of the decimal, times 10. I carry my times 10 stuff. I've got 23 and -1, so I'm going to have 22. I add the I add the exponents together. So 23 and -1 is to the 22nd. And this is my answer. This is my final answer, and that's how you work it out. Thank you very much.